The scientific method is a systematic approach followed by all scientific disciplines. It follows 6 main steps: making an observation, asking a question, building a hypothesis, conducting experiments, the interpretation of data, and finally the derivation of a conclusion. The scientific method starts with an observation and a question to help understand that observation. For example, the French chemist Antoine Lavoisier observed the phenomena of combustion. He formulated a question to understand what happens when something is burned. Where does the matter go? The third step in the scientific method is building a hypothesis, a tentative explanation for the observation in question that can be tested. In response to his question of where does the matter go, Lavoisier hypothesized that in a chemical reaction, the matter was neither created nor destroyed. A good hypothesis is also testable and falsifiable. A testable hypothesis is one that makes predictions that can be confirmed by experimentations or observations. It is falsifiable when it can be refuted by experimentation. The fourth step in the scientific method is experimentation and data collection. Experiments are observations or measurements conducted under controlled environments, such as temperature, pressure, or volume. This step investigates how well the real world fits that predicted by the hypothesis. Some experiments and observations are qualitative, describing how a process happens. Others are quantitative, measuring or quantifying something about the process. Lavoisier tested his hypothesis by heating mercury in a closed setting. This led to the formation of a reddish substance. His experiments were quantitative, so he carefully recorded the mass of the reactants and the products in the closed system as well as separately. The fifth step is data interpretation and analysis, evaluating whether the results support or refute the hypothesis and if further experimentation is needed. Lavoisier observed that the total mass of the jar and its contents before and after the reaction remained the same, although the mass of the red product was greater than that of the original mercury. The final step is to draw a logical conclusion and decide whether to accept or reject the hypothesis. If the results support the hypothesis strongly, then it is accepted. It may also be put to further testing or refined by asking new questions and conducting new experiments. From his experiments, Lavoisier concluded that since the total mass of the jar remained unchanged during the reaction, the oxygen in the jar had combined with the mercury to form the new product, now known as mercury 2 oxide. This conclusion strongly supported his hypothesis on the conservation of mass, that the total mass of the objects remains unchanged during the process of burning. However, if a hypothesis is disproved, then scientists may formulate a new hypothesis by taking cues from the failed experiments and start afresh. Even though we see the scientific method as a series of steps, new information or ideas might cause a scientist to back up and repeat steps at any point during the process. Thus, the scientific method is an iterative process.